First A plus B will be evaluated, then the result of it, and then divide by D will be there. And for right to left, from right.
Wait for like 2 more minutes for other people to join, and then we will begin your class. Our topic of this week is selection statements. So before other people join, let me show you something. So let me straight away go to the meeting. Also, do you people have any quiz this week?
Yes, sir.
Yes, sir.
How many?
2 quizzes.
Okay, so inshallah, I want to take a quiz after the Eid. Okay.
Okay, sir.
Up to the topics that I cover. Anyways, so if you remember in the first class where I came, I just spoke about structured programming, or what a structured programming is. And I said that it mainly has 4 components. The first one is statements or segments. The second one is selection. The third one being iterations. And finally, the fourth one being recursion. Now we have already taken a look at this, right? It is done or partially done. We have taken a lot of look at a lot of statements, how they're evaluated sequentially, and now I think you people are familiar with how statements work. Now our next target would be to cover selections. Now our today's topic is all about this thing, selection. Now in C, selection, we can basically divide it into 3 parts. First, we need to learn about logical expressions, the things that are used to control selections. After that, we can take a look at the if statement, and then there is something called a switch statement. However, I should be covering them all within this week, but if I want to do them directly in the class, all 3 of them, it might put a bit too much pressure on you. I've seen in the formatted IO class, and I don't want to do that. So are you people fine that if I, by myself, directly in the class, cover up to the if statements, and then I provide a video lecture, I will record myself of explaining switch statement and how to use them, and then upload it so that you people can watch it and leave comments there if you have any question relating to that. Are you people fine with that?
Yes, sir.
Yes, sir.
Okay, then let us begin today. So first, what are selection statements? Now, as I have discussed before, in a structured programming language, there needs to be some kind of control structure or control construct that can choose an option between multiple alternatives that, based on some condition, you need to execute something. Now, there are 2 main types of selection statements in C. First one being if statement, which is the most commonly used one, and most of the programming languages have this if statement. And second, there is a switch statement. We'll take a look at it later. And additionally, there is a conditional ternary operator that behaves like the if statement. We'll also take a look at it. Now, first, what are those conditions? They choose an option between alternatives based on some conditions. Conditions are logical expressions, and they verbally evaluate to things like yes or no, true or false, on and off, and things like that. How? If we take a look at real life example, like if you want to watch a game, you need to have the tickets, right? So if you have ticket, you can watch the game. Without having the ticket, you cannot. So this is a logical expression, or we can say that this is something, this is a logical expression. How? You have ticket. The answer will be either yes or no. So if you have the ticket and the answer is yes or true, or in some cases you can also express this like on and off, if the switch is on, those kind of things. If the answer is yes, only then you can watch the game. But if you do not have it, you cannot watch it. So this step will be skipped or not executed. So they're generally represented using true, yes, and on, right? So let's talk about something. I think last week in computer fundamentals course, you people covered like binary, octal, and hexadecimal number systems, right? And
Yes, sir.
in this week, you're supposed to cover Boolean algebra. So Boolean is like a data type or system that only consists of true and false, or basically a binary number system, 0 and 1. There can be only two states. It's either false or either true. So as we have discussed, the logical expressions can only be evaluated to either true or false. Now, many other programming languages have a separate data type called bool or logical data type. However, C does not have them. Instead, C directly uses integers or numbers to represent logical values. How? One will be evaluated to true. In any kind of logical expression, when C is evaluating them, if it comes out as true, when they come out as true, we will take a look at later, at the right after this one. So if it is true, C will produce the value 1. And if it is false, C will produce the value 0. However, when we are asking C to determine whether something is true or false, any number other than 0, any number other than 0, it can be 1, it can be 1.5, it can be -5, it can be -3.5, anything like that, it will be evaluated as true. Only 0 is false, and any other number is true. And then in order to build logical expressions, we need operators, just like any other expression. Like then there are relational, equality, and logical operators. Remember, you can also use arithmetic operators inside this type of expressions as well. All the operators there are, in most of the cases, you can mix all of those to produce the final statement. However, if you use any of these, like a relational, equality, or logical operator, that part becomes a logical expression. We just verbally call it logical expression. Generally, it is evaluated like any other expression. So first of all, what are relational operators? Relational operators are just like the operators in mathematics that we commonly use. There should be an equal to sign here. I forgot it anyways. So except they produce the value 0, true, 1, true, or false. So what are they used to? So what are they used in? Like we can use them to compare whether a number is less than another, or whether it is greater than another, whether it is less than or equal to another, or whether it is greater than or equal to another. So if I want to show you, it was relational operators, and it will something like this. Right. Let's have two integers. For now, let's just use integers. A is equal to 5, B is equal to 10, and I can write E is greater than and the evaluation finally. Since they are integers, we will also print the results using %d. So what we will do, A, comma B, comma A greater than B. This A will be put here, this B will be put here, and finally A greater than B. This evaluation, whether it is true or not, will be put here. And finally, if I compile them, okay. So If you run this code, so I think this thing clutters up the screen for you. Let me use my terminal instead. So if I run, is 5 greater than 10? The answer is 0. But if I change it up, write it like A is equal to 10 and then B is equal to 5, then it will be asking whether 10 is greater than 5. And what would be the result of this % D? Or like A is greater than B? Can anyone tell me?
One.
Right. So if I do, right, is 10 greater than 5? The answer is 1 or true. So relation operators can compare mixed types as well. That means we can mix integer, floats, and any other expressions as we like. Is 10 less than 11? The answer will be false because 10 is not. Is 1 plus 2? We can also use arithmetic expressions here as well. Or we can also use variables here as well. Anything we like. 1 plus 2 greater than 0.5? The answer is true. And yes, the mixed expressions. 5 plus 3.5, 8.5 greater than 10? 0, false. Now, the precedence of relational operators, that means greater than, less than, greater than, equal to, less than, equal to, are lower than arithmetic operators and they are left associative. Meaning, this part and this part will be grouped together first, and then finally the relational operator, relation expression will be evaluated. Now, there is a common problem with relation operators or mistake that people make. Can anybody tell me what does this relational expression mean in C? How many of you think that this will evaluate whether J is between I and K? Like in mathematics, when we write like something like this, 3 less than x less than 5, it says that x is a value which is between 3 and 5, right? Exclusively, not inclusively. So if I write I is less than j and less than k, or something like this, if I write integer I is equal to 5, j is equal to 7, and k is equal to 9. Evaluation is %D. Okay. Anyways. So what will this statement evaluate to? Can anybody tell me? I less than j
I
less than
think
k.
it will be 1 because it evaluates first if I is greater than j is greater than I or not, which is true. So the answer will be 1. Then it checks 1 is less a is greater than 1 or not. So
Yes,
which
correct.
is also true.
So
the answer
yes,
will be 1.
instead of checking whether actually j lies between 5 and 9, it does a little bit differently. What it does in C, it evaluates the first part first, I is less than j, it evaluates I is less than j, or whether 5 is less than 7, and this thing is true. So it will be evaluated to 1. And afterward, it just checks whether I is less than k. That means, sorry, whether 1 is less than k. That means whether 1 is less than 9 or not, which is also evaluated as true. So instead of checking whether 7 lies between 5 and 9, it actually checks whether 5 is less than 7 and then whether 7 is less than 9. So do not make this kind of mistake. Like writing I is less than j is less than k, because in some cases it can produce wrong results. So I is less than j is less than k. It does not check whether j lies between I and k. Rather, it first checks whether I is less than j, which will either return 0 or false, and then it checks whether the previous return 1 or 0 is less than k. So if I write something like this, I is 7 and j is like 5, still the evaluation will be true. Why? The overall evaluation? Yes.
Sir, if it is not true, then 0 will come and 0 is less than 9.
Yes, that's why. Because if it is not true, first, this part is not true. So it will be evaluated as 0 because 7 is not less than 5. This will be evaluated to 0. However, 0 is less than k, 9. That's 0 is less than 9. That's why this whole thing is evaluated as 1. So is there any way to write the thing that we have written here? I is less than j is less than k. Yes, there is a proper way, and that is to use logical operators like I is less than k and logical and j is less than k. We'll take a look at it in the logical expression section, logical operator section. Now we'll take a look at equality operators. So the equality operator checks whether two operands are equal or not. Remember, this is not the assignment operator. This is the equality operator. The assignment operators that we have checked before has only one equal sign in there, and they assigns a numerical value or some value to an operand or to a variable. However, this equal to sign actually compares whether two values are equal or not. And then we have the not equal to sign, which compares whether two values are not equal or not. And they can also work with mixed types. And you can use expressions. You can also use variables here as well. How? If you take a look at them. When you ask whether 5 equal to 6, that means whether these two values are same, it will return false because 5 and 6 are not same. When you ask 2 plus 2 equal to 4, it will return 2 because 4 is equal to 4. And whether 5 is not equal to 6, yes, it's true. 5 is not equal to 6, so it will return 1. And whether 5 is not equal to 5, and that will produce false because 5 is equal to 5. And they have lower precedence than relational operators, and they are left associative. That's why arithmetic operator has the highest precedence. They are grouped together first, then the relational operators, and finally the equality operator. And do not mix up equal to operators with the assignment. Equal to or equality operators with the assignment operators is a very common one. Why? Because if I is equal to 5 and you want to evaluate whether I is equal to 6, the result will be 0. However, if you just assign the value 6 to I, this whole statement will return 6. And remember, as I have said in the very first slide, is that when you're trying to evaluate any expression, if the value is not 0, it will be treated as true. So this thing is false. However, this thing is always true. However, if you assign the value 0 to I, this thing will always be false as well. So remember, do not make this kind of mistakes. This is a very common one that people tend to make when they start writing programs. So I have actually written something to test many kind of equalities. Don't worry for now how this thing is working. This is just a shorthand thing, or more like a test framework that just does the thing for me. So if I run this program, this thing just checks and prints out whether these two things are equal to or not. So this is a comparison between an integer and a double. This is a comparison between an integer and a double, an integer and a float, and similarly like this. So if I run this, so just 0 is false. I've run the wrong program. Sorry. So this thing will be evaluated as true. This thing are equals. This thing are equal. 0 and minus 0 are actually equal. 1 is not equal to minus 1, and you see all of this works as well. When you're using mixed type, it will work just fine. Now we will move on to logical operators. You will be taught these things, logical operators or logical operations elaborately in computer fundamentals course this week. So I will just cover them in short, like what are logical negations, what are logical and what are logical or. So in order, we have only seen simpler expressions till now, right? If I go there, simple expressions like whether I is less than k or I is less than j or things like that. If I want to have a very large expression, like if you are older than 18 years and if you are a citizen of Bangladesh, then you can vote. So I have combined two conditions here. First one, you being older than 18 years, and second one, you being a citizen of Bangladesh. So these two conditions are combined together using a logical operator, and that logical operator is AND. That means both of them needs to be evaluated to true. Now, if we take a look at all the logical operators here, only NOT, logical NOT is a unary operator. It only works on one operand and it just flips the value. That means if A was true before, it will become false, and if A was false before, it will become true. Like it will just flip the value. Then there is the AND operator, which is a binary operator, and it takes in two expressions, A and B. If both of them are true, if A is true and if B is true, only then the overall evaluation will be true. Like if you are 18 years old, more than 18 years old, and you are a citizen of Bangladesh, and so there are two conditions, both of them needs to be true, and then the final evaluation will be evaluated as true. However, in case of OR, yes, any question?
Sir, I didn't get the point not.
Okay, not. So what will happen in case of not, if I want to show you? Let's just see. Right, not as an exclamation, as an exclamation mark, and then we just put the value there. What happens? Not will just flip the value. If it is true, it will now become false, and if it is false, it will now become true. That means if it was 0 before, not I. If I was 0 before, not I will be 1, and if I was 1 or any other value, it will, after doing not, it will become 0. Let us take a look.
Yes.
It was 0 before, it has now become 1. And if I want to do it the other way, if I was 1, and it will now become 0, right?
Sir, if we put any other value
Yes,
than 1, for example 2, will it produce 0?
Okay, so let's just put 20 there, right? Not why just 2, let's just put 20 there. What do you think what will happen?
So it will produce 0, I think.
Okay. So there was a statement that I have said in the very first or second slide, is that any value other than 0 is treated as true. So if 20 is true, what is the opposite of true? False, right? So 20 will also become false, and only 0 is false. That's why it will become 0. So 20 also becomes 0 when we not them. What will happen if I have minus 20 here?
So still 0.
Yes, minus 20 is also true. Any value other than 0 is considered true, and their not will produce 0. Only 0 is false, and their not will produce 1 or true.
Okay.
So, yes, in logical operators, we can also compare mixed type like floating point and floating point numbers and integers. So yes, 5 and 3, which is 8, and not of 8 is 0, not of 0 is 1. 5 and 0, since there is one operand 0, so 1 is false, and it will always be considered false since AND requires both of them to be true. That's why 5 and 0 is 0. 1 and minus 2.2, both of them are true. That's why it is true. In case of OR, if either one of them is true, like if the first condition is true or the second condition is true, then the whole statement will be evaluated as true. What? How? So if you have a ticket or if you have a VIP pass, you can watch the game, right? So if you need either a ticket or a VIP pass, if you have both of them, yes, you can watch the game. If you have only one of them, you can still watch the game. However, you cannot watch the game if you have none of those. So that's what OR is. Both of them needs to be true in order for the whole statement to be true. Let us see some example. 1 minus 1.0f and then 0. So this one is evaluated to 0, 0 or 0. Both of them are false. That's why in case of OR, the output is false. However, here one of them is true. It can be 20, 20.5 or any other true value, and the whole evaluation will be true. So not has the same precedence as unary plus or minus, since it is a unary operator, and it is also right associative. Right associative mainly for the fact that it is a unary operator. You can put 3 or 4 nodes together as well if you need for or if you need them for mathematical or logical reasons. Anyways, and has higher precedence than OR. Remember, however, both of them has lower precedence than relational and equality operators. That's why if you take a look at this example, and has higher precedence than OR. So I and J will be grouped together first, then J and K will be grouped, and then all this thing JKL will be grouped together because they are left associative. Now, if you're confused about the precedence of the operators, I have provided a link in the previous slide which lists all the operators in C, their precedences and their associativities. You can take a look at that list in CPP reference. So here is a very important thing that people often looks over, which is called short circuit. When we're dealing with AND and OR, the logical and the logical OR operators, they are evaluated in a short circuit fashion. What does that mean? It means they are evaluated from left to right because they are left associative. However, if the left value is sufficient enough to determine the outcome of the overall expression, then the right operands are skipped. So let me give you an example. Suppose you want to drive a car in Bangladesh. You need to be greater than 18 years old. You need to pass the driving test, and only afterwards you can drive, right? So if you're less than 18 years old, do I need to check whether you have passed the driving test or not?
No, sir.
Right. If you're less than 18 years old, there's no need to check whatever comes afterwards, right? So I will check first. The first thing is whether you're less than 18 years old. I see that you're less than 18 years old. Okay, let me check the next condition, whether you have passed the driving test or not. I do not need to check whether you have passed the driving test or not because you're already less than 18 years old. So I will skip them. Generally, they do not make any differences in case of evaluation. How? Okay, so this is a very common thing. If I is not equal to 0 and logical and J divided by is greater than 0. If we hadn't checked this, I is not equal to 0. This will cause a division by 0, right? Because if this thing evaluates to false somehow, only then we will check this. Yes. If this thing evaluates to true, only then we'll check the second condition, right?
Yes,
That's
sir.
how AND works,
Yes,
or
sir.
short circuit works. First thing is to be true, and if first thing is true, then we will go in depth to check whether the second expression is true or not. If the first expression is already false, then we do not need to check the second ones. We can just skip it. So if this thing is true, that means I is not equal to 0. In that case, there is no problem dividing something by I, right? Dividing by non-zero value is fine.
Yes, sir.
However, if we hadn't checked it, we would be dividing a number. We might be dividing a number by 0, right? Because
sir.
if we do
Yes,
not
sir.
have this, I can be 0. This is the one that says that I is not equal to 0. If this is true, we will take the next one. However, if this is false, we will not check this one. That means we will not do this kind of operation. So normally, they will not do any kind of like bad things unless you write something like this. In that case, if I was 0, it might produce some error and your program might hang because it's unimplemented how to handle divide by 0 error in C. However, if you write one statement like this, I is greater than 0, and let me just copy this statement. I is greater than 0 and j is equal plus j is greater than 0. Let's say I is equal to -1 and j was initially true. So after the execution of this statement, can you tell me what will be the value of this whole statement? What will be the value of I and what will be the value of j after the execution of this whole statement? What will the value of this statement? I is greater than 0 and then plus
It
j.
will be false.
It will be false.
False.
Okay.
False, sir.
Okay. What will be the value of I after the execution of a statement? Okay, since there is no operator with side effect involved with I will be -1. What will be the value of j?
3.
J will remain 2.
J will remain 2.
J will remain 2.
Exactly. J will not become 3. J will remain true. Why? This statement was evaluated to false. And the compiler says that the next statement is in an AND, logical AND relationship with this one. If this one is false, then we can skip this one, right? We can skip this statement due to short circuit rule. And so this will be skipped and plus j will not be evaluated, or it will not be executed at all. This whole thing will be skipped. And that's for design reason, and that's for efficiency. We might have a large statement, but we don't need to evaluate them. So this one will be skipped. And so the value of j will not change. However, if I was something like 3, in that case, this whole thing will evaluate to true, right?
Yes, sir.
This whole thing will evaluate to true because 3 is greater than 0. This one is true. Also, 2 is greater than 0. That's also true. And then afterwards, the value of I will be 3 and j will become, sorry, this one is not 2. This one was 3 and j will be 3. Is it fine? Yes, pretty good. Similarly, similar thing actually goes for OR as well. Let's say if I is, let's do the same thing but put OR there.
Sorry, instead of ++j, if you write j++ in the previous equation line, then what would happen?
It would still remain the same because if it was ++j, what is being done? 3 is greater than 0. This is true, and ++j, this will be evaluated as 3, just 3, because it is pre-increment, and 3 is greater than 0. It is true. It's fine. If I write j++, it's just whether 2 is greater than 0 or not. The answer is yes, it's true. Still, but if I write,
Sorry, if the first condition was not true, then
still it would not make any difference if like I was -1, right? In that case, this part is never executed. You will just skip this part. Okay. So whether it is ++j or j++, it doesn't matter. C simply doesn't see this. Nothing exists there. Okay. It just skips that part. If this one is false, C will simply skip the next part. Okay. It will not be evaluated. So whether it is ++j or j++ or maybe something like this, j is equal to 5,000. It doesn't matter. This part is being skipped. Are you getting me?
yes, sir, I got it.
So since this one is false and they are in an AND relationship, it doesn't matter whether I have true or false here. The overall evaluation will be false, right? If the first part is false and they are in an AND relationship, if this one is false and just like the example that I gave, let's say what you need to do okay, let me just come up with an example. Let's say you want to arrange a very good party. So here are the conditions. In order to arrange a very good party, you first need to book a place to hold the party. Then you need to decorate that place very well. you need to hire the cooks to cook in that place while you monitor them. And finally, you need to eat with your friends exactly at that place. If you haven't booked or rented that place, does the next step matter? Whether you're decorating that place, whether you are inviting people to cook there, and whether you're eating there or not, it doesn't matter, right? Because you haven't booked that place. So if the first thing evaluates to false, there is no need to check the next ones in case of AND. Let me give you an example with OR. Let's say I is equal to 3, j is equal to 2. Whether I is greater than 0, and if afterwards j plus plus will be greater than 0. And let me also, okay, I'll not make it complex right now. Let's just put the AND part here. Tell me what is the evaluation value of this statement and has higher precedence than OR. So and will be evaluated, this part will be evaluated first. So tell me what after the evaluation, what will be the value of this statement, what will be the value of I, and what will be the value of j after we execute this whole statement. Anyone?
I will remain 3.
I will remain 3.
J will remain 2 actually.
J will remain 2.
No, so,
And what will be
Sir, J will be 3.
J will be 3, yes.
Okay,
J
now
will
you're
be 3.
confused whether J will be 3 or 2. Okay. Anyways, so before going there, what is the evaluation of this statement?
One.
True or
True,
false?
one.
True.
True.
Okay, so 1, true or false, all the same. Okay, you're saying it's 1. Let's check what happens actually. Is J less than 3 or is 2 less than 3? Yes, true, right?
Yes, sir.
Since
Yes,
this
sir.
is true, this part will be evaluated, right?
Yes, sir.
Okay. So is 2 greater than 0? Sorry, is 3 greater than 0? Is 3 greater than 0?
Yes, sir.
Yes, right?
Yes, sir.
So this one is true. This one is also true, right? Like we have true, true, right? So the whole thing will be evaluated as true. Now comes the OR part. Will this statement be executed?
No, sir.
No, sir.
No,
Yes.
sir.
It will not be executed. Why? Because if we have true in the beginning, in case of OR, like in order to like go to your school, you either need to hire a car or you need to get on a bus. If you have hired a car, I do not need to check anything related to the bus. Or if you have get on a bus, I do not need to check anything related to the car. Or if I want to say in other way, in order to purchase the product, you either need to have cash money or you need to have the credit card. In order to be able to purchase the product, you either need cash money or you need to have a credit card. If you have a cash money, I do not need to check whether you have the credit card or not. You're already able to purchase. And if you have the credit card, I do not need to check whether you have the cash money or not because you're able to purchase using that credit card. That's why when the first statement is already true and they're in an OR relationship, and in case of an OR relationship, if any one of them is true, the whole statement will be evaluated to true. That's why this part is not actually checked and this part is not actually executed, and hence J will remain 2. And the whole statement will be evaluated as true. Or 1, whatever it is. Actually, this one. Got it?
Sir,
Yes? Should I explain
sir,
again?
if any of,
Or
yes, sir,
again?
if any of the statement or condition is false, then the whole statement will be evaluated as false. Yes, sir.
It depends. In case of AND, if it is AND, if any of them is false, the whole statement will be evaluated as false. Let's say I'm writing A for false now and P for true now. I can also write 0 for false. Let's just say 0 or 1. 0 is false, 1 is true. 1, 0, and then let's say the statement is written like this, and they will be evaluated like 1 and 1. This whole thing will be evaluated first. Their value will be evaluated with this one. Their value will be evaluated with this one, and so on. The compiler first says 1 and 1. Okay, the evaluation is 1. There is still hope that the overall statement can finally turn out true. Then 1 and 0. This whole thing evaluates as 0. Now, since rest of the things are also ands, the compiler will just say, I do not need to check anymore. As long as anything is with AND relationship with me, it will be 0, because I already have a 0 as left operand. Whatever comes as the right operand of AND doesn't matter, right? It will be 0. That's the rule of AND. 0 and anything is always 0. So if I do a chain of things, doesn't matter. As long as they are in an AND relationship, this part will be skipped. It doesn't matter whether it is 0 or not. The whole thing will be evaluated as 0. This part will be skipped. It doesn't matter whether it is 0 or 1. It will be evaluated as 0. Got it? And the OR is simply opposite of this. That is, if anything or any operand is once expressed or evaluated as 1, OR will not check any more thing that is in relationship or that is in a OR relationship with the operand. Like, let's try to evaluate this thing. 0 or 0, this thing will be evaluated as 0. There's still hope that the overall statement will be turned out as 0 or false. 0 or 1. What is the value? 0 or 1, the value is 1. Now, in case of OR, if any one of the operand is 1, the overall evaluation is 1. That's why, as long as the other operands are in OR relationship with this value, the compiler will simply evaluate them as 1 without checking the right operand at all. So whether it is 0, whether it is 1, or whether there are some other expression that has lower precedence than OR, actually, there's very few, it doesn't matter. They will not be executed. If I write something like I is equal to 0 in the middle, it will not be executed. Simply this whole part will be skipped and evaluated as 1. This whole part will be skipped, evaluated as 1. This whole part will be skipped, evaluated as 1, 1, and then 1. That's how short circuiting works. That means if my left operand is enough, to judge the outcome of the logical operation, that is AND or not, only the left operand will be used and right operand will not be used. Okay, got it? Or should I try to explain more?
Sir, I think we have got it.
Okay. So that's our logical expression. Now the problem that I was facing. If I try to cover if statement, I will definitely cross the 30-minute marks. Because it's just too long. And let me just cover a little bit of if statement. All of these things that we have been reading are basically to build the basic that we need to cover the if statement. And the if statement basically chooses between two alternatives by testing an expression or condition. What are those expression or conditions? The things that we have seen till now. If, this is the simple form, if expression, then the statement will be executed. If this expression evaluates to true, only then this statement will be evaluated. Otherwise, it will just move on. Like integer is equal to 19. If age is greater than 19, only then if you print, you can vote. If I copy this code, write it here. I compile and run this. You can vote. How did it work? 19 is greater than 18, right? since 19 is greater than 18, this statement is evaluated as true. Is 19 greater than 18? True. Then you can vote. However, if I make it something like this, age is 5, the program will not print out anything at all. You see, nothing was printed. If I want to just give something for safety, let's just scan the age for now. Safety statement here. Now, if you want to run this, enter your age. If I enter 20, 20 is greater than 18, that's why it's printing, you can vote. However, if I enter something like this, 5, it's not printing anything. So there's one more thing that we can do. So I can do one more thing. That's called the else clause. That means this is the option, or this is the statement that will be triggered when this value evaluates to true. Is age greater than 18? If it is true, this statement will be executed. And this is the alternative one. That means if age is not greater than 18, what will happen? You cannot vote. So remember, look at the syntax here. If, then condition, then the statement, or a conditional expression and then the statement. Else statement. If I run this, compile and run this, enter your age. If I put something like 19, you can vote. However, if I put something like 2, you cannot vote. See here. Okay. Greater than 19 is true. Less than 2 is not false, so the alternate route is taken. So this is the general thing. These are the two options. Yes.
So if we gave 18, then it will show nothing, right?
Why? Okay. Is 18 greater than 18?
No.
It is false, right?
Yes, sir.
So which path will be taken?
Oh, you cannot vote.
Yes. So, however, if works this way, this expression is evaluated to either true or false, right? This expression is evaluated to true or false. If this expression is true, this path is taken. Okay?
Yes, sir.
If this value is false, in that case, this path is taken. And afterwards, all the other codes are executed.
Okay.
Okay. Think of this as a single block. This thing is executed only if this is true, and this one is executed if this is false.
Sir, can you put expressions, conditions in else statement?
No, you cannot put conditions in this else statement. Else is the alternate route. This is what to execute when this expression is true, and this is what to execute when this expression is false. Both of these are linked with only this expression. Okay? That's why. Why do you need to put an expression here?
Sir, for modifying something like if it is less than 5, then another condition or another comment.
There are ways, but I will tell you how to do it. But this else is linked to this if. According to the rule of C, when C sees an else statement, it tries to find the nearest if statement that is not linked with an else. So this else actually belongs to this if. If this is true, this part is executed. If this is false, this part is executed. Okay?
Okay, sir. Thank you.
Just two paths. Now, can someone tell me if I write something like this, if minus 2.5647, you can vote. What will it do?
So it will print you can vote because minus is true.
Yes, minus, yes, minus some other value is also true. What will happen in case of minus 0?
Sir, it will show you cannot vote.
Yes, minus 0 or 0 are false, and hence it will print you cannot vote. It is greater than if we also want to if we also want to check whether you are a citizen of Bangladesh or not, right? Let's just scan that one as well. I will just input 0 or 1 manually for now for this one. So I need to check two conditions, right?
Yes, sir.
Okay. There are two ways. I can check the condition here. Right?
Yes, sir.
I can check the condition here because now this is a logical expression. Is age greater than 18? Yes or no? And are you a citizen? The answer is yes or no. That's how it will be evaluated. It is greater than 18 and are you a citizen? So this value, if I put any other value for each citizen other than 0, it will be true. And any other value, if I put 0, it will be false. Yes. Okay. You didn't get the. Okay, I'll explain that. Okay. Let me just get back a bit. This actually evaluates to true. Minus 5.72381 evaluates to true because according to the rule of C or how logical expressions are evaluated, only 0 is false. Only 0 is false. All other values are true. Whether that be minus, whether that be plus, doesn't matter. All non-zero values are true. That's why minus 5.72381, this is a non-zero value. Hence, this is actually true and this statement will be executed. Okay. So if I put it back, I can use logical expression and to bind this thing together. The greater than symbol has higher precedence, or if I'm confused, I can always put a bracket here to make sure this one is executed first. So what happens now? It checks first whether age is greater than 18. If it is true, it checks whether are you a citizen. And if both of them are true, only then it prints you can vote. If you compile and run the program, enter your age. Let's say 20. Are you a citizen? Yes, I'm not. 0. You cannot vote. Okay. Age 15. Are you a citizen? Yes. However, this will never be checked. Why? 15 is greater than 18. This will be evaluated as false, and hence the next part will never be checked. You cannot vote. My age is 20. Are you a citizen? Yes. You can vote. Got it? We have used logical expression to chain them together. There is another way which is commonly used for when you are checking like multiple conditions, whether something is greater than other value and it is between another range, and that is, okay, let's get one thing clear. We're checking them step by step, right? First, we are checking whether age is greater than 18 or not. If age is greater than 18, then we are checking whether you are a citizen or not. We can write like this. If age is greater than 18. If citizen, then you can vote. Yes. So this is called a nested if statement. Now this is getting cluttered and difficult to understand which else and which if belongs to which one, right? A bit difficult. So what we can do, just like our main function has these curly braces to show us where they begin and where they end, we can actually put curly braces inside if. They serve two purposes. Okay. The additional or the extra benefit is they make the statement look clear. But actual benefit is we can now execute multiple things that belong to if. You can vote. I can put some more statements here. Printf citizen. Oh, sorry, this will not work. In case of this printf actually, yeah, I'll get an error. So in order for me to put multiple statements inside this if, this is called a compound statement. Let us just take through the slides to match them properly. Yeah, this is the simple form of if. If age is greater than 18, you can vote. However, it will only match the immediate statement that comes after if. If we want to use multiple statements that will be executed based on the evaluation of a single if, we need to use something called compound statements. And compound statements are basically statements within a curly brace, like we use for the main function. Each of the statements themselves should end using a semicolon, just like normal things. Example, okay, they are generally put on separate lines to make it clear to read, like here. Age 20 is citizen. We're trying to combine both of them. If age is greater than 18 and is citizen, you can vote, you can drive. Yes?
So we actually use multiple conditions in the if statement. So if condition 1 and condition 2 and condition 3 and condition 4.
Yes, you can. Yes, you can do as much as you like.
And so does the same thing apply to or statements?
Anything. You can make it if age plus 2 greater than 18 and is citizen, and I'll just put anything that age must be less than 60. I'm in a weird country where the voting right gets revoked after you are 60. I can make it as much long as I can. Or I want to make another thing that you are some kind of a special person. And I put something like this. Special. And you can put like this special. That is fine. Make the statement as large as you want. At the end of the day, when this thing will be evaluated to either 0 or 1, right?
Yes, sir.
And that what determines whether this statement will be executed or that statement will be executed. For now, yes, we can see that only one statement that comes immediately after if is executed if this whole value equals to true. Otherwise, this single statement is executed. If you want to treat multiple statement as a single statement, what we do, we use compound statement. This is a compound statement, okay? Like if this happens, is special. One can use is special power only once. I can set this value to 0. I can like maybe increase something. I'm just writing weird things, but you get it, right? Like if I want to be more reasonable. And whenever you're reading any code, you'll see most of the time people do put these curly braces around. Why? Because they make them easier to read. And you can actually see what are the statements that belong under the if condition, if this condition is true, and what are the things that belong to else condition if this is false. Okay?
Yes, I got it.
It lets you combine multiple statements together to be executed when this value equals to true. And it makes it clear to look at. And you will also be using them in loops and other places. So the if expression may also have else clause. That means if this value is false, then the else clause is executed. Yeah. This is a very common one, right? Let's say two numbers. Integer I, integer j. Enter number 1. if I want to find out which one of them is the larger among these two, what do we need to do? Or which is the maximum value between I and j? We need to compare whether I is greater than j, right? If I is greater than j, then I is the maximum number among these two. And if I is less than j, then j is the maximum number. What we can do, we can write it if. This bracket after is mandatory. That's part of the syntax. If I is greater than j, then we can say that max is equal to I. Otherwise, else.
Sir, can we use max as a variable?
Max is a variable.
It will get sorry, it will be in C++, sorry.
No, in any other, even in C++, it is fine. You can, use whatever you can do write any statement here. Even in C++, you can use max there. Even in C++, not even just C++, any other language, you can work with variable there. Otherwise, there is no meaning to the programming language. You should be able to modify values and work with those.
So it will work as a max function for MySQL actually.
It's fine. There is no conflict here because I haven't imported any library that compares max already. So the symbol doesn't conflict with any other thing. I can use max as a variable because if let's say I have something, a function or some other library which contains a max function that automatically determines the maximum between multiple or two values. In that case, I'm trying to use an identifier twice, right? One cannot declare an identifier twice. An identifier can only be declared once. That's why since I have no other thing which is known as max, it is fine. I can use max as a variable, as an identifier of a variable. Anyways, if I is greater than j, then max is equal to I. Otherwise, max is j. Is this thing clear to all of you? What?
Yes, sir. Yes, sir.
Is first comparing I with j, and if I is the larger one, then max is I. Otherwise, max is j. And then I can use printf. Max value is and what if I want to determine whether number 1 is maximum or number 2 is maximum? I want to print that yes, number 1 is maximum, or I want to print that number 2 is maximum. What should I do? Can anybody tell me? Anyone? I'm just printing the value right now, right? I'm determining the maximum value among these two numbers, I and j. However, I want to write whether number 1 is the maximum or number 2 is maximum. What should I do?
If I greater than if
Continue.
Because my idea is I is equal to max, then we will print I is maximum, and if not, then else. By using else statement, we will print j.
Okay. If we want to print right away, we can print here. Printf. Number 1 is maximum. And we can print right here. Number 2 is maximum. Okay. So if I is greater than j, in that case, number 1 will be maximum. It will first print this. If I is greater than j, if this statement is true, first the value of I will be copied to the value of value max, and then it will print out number 1 is maximum. Else clause will not be executed. Since this was true, it will jump to this place. Max value is I. Max value will be printed. And if this thing is false, like I is 2, j is 5, in that case, this part will not be executed. It will move to this part. This part will be executed. Max will copy the value of j. The value of j will be copied to max. Then it will print number 2 is maximum. And then finally, it will print the maximum value.
Sir?
Yes?
Do we need to use the max variable in the previous one?
If you want to print here right away, like you can do it here as well. That's fine. In that case, if we put 2 copies of them here, can print them here right away. There are multiple ways to achieve the same thing. Whichever you want to follow is fine. Did you get it, all of you?
Yes, sir.
Like if I enter 5, enter 2, it will print number 1 is maximum and max value is 5. If I run it again, 2 and then 5, 54, whatever. Number 2 is maximum, max value is 54.
Sir.
Yes.
Here, do we need to declare the max variable because we can work through just only printf?
Yes. This amount, this code is fine. You don't need to use the max variable.
Okay, sir.
Okay. We can just work through printf. So this will do the same thing as the previous program. And we can also write it in a single line if you want, if I is greater than j, max is equal to I. Remember how many lines you are writing?
Sir, I cannot hear your voice.
Is it fine now? Am I audible now?
Yes, sir.
Yes, sir, you're audible.
Yes, sir, you are audible to us.
Okay. So we have seen the else clause. The next thing is nested if statement. I have shown a bit to you, and then there are also indentations, braces, and cascaded if statements. And there is a problem regarding if statement. We will see them in the next class. So I do not know how much I actually didn't plan to cover if statement right away in today's class. But you people grasp the first part quite early. Both sections do not move at the same pace, so I need to balance between two sections. That way I have taught you half of if statement, and it was like also done in a half-baked way. Anyways, if we want to give a cover of if statement again, it chooses between two alternatives by testing an expression. If an expression is true, only then the statement is executed. If it doesn't have any else clause, the flow just moves to the next part. If this value is evaluated to true, only then this statement will be executed. Otherwise, it won't. Compound statements are used so that you can put multiple statements under the control of a single if. Compound statements are written in between two curly braces, and each of the single statement within them ends with a semicolon. Like this is a common thing, and people generally write them in multiple lines so that it is clear to read. Again, in C, indentation doesn't matter, so do not think that indentation can change anything. This whole thing can be written like this or this. It is completely fine. And when you're using if statement, this is an example of a compound statement. Both of these statements belong under this if this is true and this is true. That means if the whole thing is true, only then these two statements will be executed. Otherwise, they won't. And they're using loops and other braces. Generally, if statements have else clause, it's not mandatory, but it may have an else clause. When an if statement has an else clause, it is linked to the nearest if statement. Okay, so the statement following the word else is executed, and if the expression has value 0. That means when this value evaluates to false, this part is executed. When this value evaluates to true, this part is executed. Like if I is greater than j, if this value evaluates to true, like 5 is greater than 2 or something like that, these statements will be executed. If this whole thing evaluates to false, these statements will be executed. Like if max is equal to I. And we can also, since this is a single line statement and we are not doing more than that, we can just put it like this. If I is greater than j, max is equal to I. If expression in bracket statement, else expression. If expression in bracket statement, else expression. Sorry, else statement. Try to match with this. Okay. And then the next topics will be nested ifs, and then else if or something like that, which is called cascaded if, just a different way to write ifs. And then we'll take a look at example, and after that we have some problems to discuss with. I haven't made slides for the switch part yet because I had some work with IoT in the previous days, so I was busy. I didn't get much time to like make the slides or take a look at to study myself as well. Anyways, so if you have any question regarding today's class, you can ask me now. Any question?
Sir, why do we return 0 after the main function? I thought it indicates a successful execution.
Yes, return 0 is actually used to indicate a successful execution. Sometimes we want to first of all, there are multiple version of the main function, right? Like integer main, void main, some other main. Generally integer main and void main, these two are used, and even in this part of main function there are multiple variances. However, this is the most common one for C, and there's another version which is the most common one, which is the argc, and then character pointer argv. This one is used for something called command line arguments. We might take a look at them later, or we might not. However, this is the most common one, integer. Why? There's something called like I can do exit 1. If I face some problem, I can abruptly close the value. Let me show you an example. We are taking two numbers and we want to divide, let's say, get the division. And it will be, let's just do integer division for now, I by j. If j is 0, something divided by 0 is an exception or is an error, right? What is the value of 5 divided by 0?
Undefined, sir.
Undefined, or sometimes it is said to be infinity, but we'll go there later. So it's undefined, we do not know, and we do not even know how C behaves. What we can do a check. If j equal to 0, sorry, I have used something called ligature, programming ligature, which actually merges symbol together. So if I write greater than equal to, it will look like general greater than equal to. So for now, ignore those. So if I like not equal to, it will just become not equal to. So if j equal to 0, this is double equal to sign. So since it's longer, it's double equal to sign. I will just abruptly exit 1, or I can use any other exit code that I design. Let's say I use an exit code called exit 5, and exit 5 means I have got a division by 0. I can write it like this. 5 means divide by 0. Yeah. And otherwise, I will do the thing normally and then just execute it. Let's just okay, right. I need to use stdlib standard. Enter number 1. Let's say 5. Let's try. That's 5 and 2. The division is 2. It's fine, right? Let's put the first number to be 1, second number to be 0. This should cause an error and exit with the value 5. I am not saying anything. Where did the value go?
Sir, as we have abruptly exited from the program.
Yes. Now, this is like bonus content. This doesn't belong to today's class. I'm using the last exit code of the operating system from my shell. I'm asking it. And see here, here's the value 5. Operating system knows the last value is 5, and I can ask the operating system to tell me about the last value. If in case of a proper execution like 5 by 2, if I check the last exit code, it is 0. Are you seeing it? The value 0. By calling this thing, this is a variable of the shell and which can return me things from the operating system. By calling last exit code, I am seeing that the last value was 0. But if I like made any kind of mistake and I query for the last exit code, it is now returning 5. Remember that 5 I asked it to return, or when the function 8, I can use exit 5, or I can also write it like return 5. Since this is the main function and not any other function, it will directly return to operating system. So I do not need to write exit 5. I can return 5 as well. So like 54 divided by 0, and I take the last exit code, it is 5. The value that the main function returns is actually passed to the thing that called that function. In my case, this shell called that function, and that's why it now holds the return value 5. What can I do from it? Not all the programs are launched by humans. Some programs are automated. Maybe you have scheduled a task to execute at some specific time of the day. Okay, so you cannot like monitor the console always, right? What it is printing or what is happening. What you can do, if somehow that program fails or some like bad thing occurs, you can make a table to return which kind of value you want to return based on some specific errors, and then this system, this shell actually holds that value, and it can also process with that value. I can write code here as well. I can do many things, like I can print out what's here, and not only that, I can actually hold them in another variable. This is another scripting language, is PowerShell language. Like I can do it like this: $A is equal to get child item. I can this one has properties as well. This one has anything as well. Like there are many things that you can do. So the overall gist is that the return code or execute code tells whether a program executed properly or not. And the universal thing is that when you return 0, it lets the operating system, or it lets the calling shell, or it lets the parent program. One program may call another one. It just lets them know that, okay, the program that I asked to execute, that has executed completely without any kind of error. That's why it is returning the value 0. If it returns any value other than 0, it generally means some kind of error occurred. And what kind of error occurred, I can make a table in my own way based on the return values and associate errors with them. In that way, I will know what kind of error that is. If it is the main function, the return is same as the exit statement. That means it directly abruptly closes the program. Return means just end the program here and return the value 5. And if it is some other statement, I need to use exit there. Like when we read about function or multiple files, how to use them, we need to use exit there. Otherwise, inside main statement, return is the value that is returned to the calling system. Let's just say calling system. Okay, is it clear?
Yes, sir.
Or did I make it more complex?
Yes, sir.
Basically, this is the value the whole program returns to the thing that calls the program. In my case, this shell is calling this program, and that's why it gets the value, the last exit code. Okay. Any question related to if or compound statements or anything? I was like a bit unprepared today. Sorry, I didn't get much time. But just honestly tell me, did you people understand like the logical expressions, relational operators, and then the basic of if that I have taught?
Yes, sir.
Yes, sir.
Yes, sir.
So I think I was a bit all over the place today. So I'm sorry for that. And the next class we'll cover the rest of the if, okay?
Okay, sir.
Okay, sir.
Okay. Also, you remember, two things that I would suggest. Do the the Boolean algebra class well. I think it's tomorrow for one section, and the day after that for another one of computer fundamentals. You will know how these expressions are evaluated. You will see something called truth tables and some other things which will help you, and then you'll be able to evaluate them better. But overall, the thing is that simple. If, else, we can use multiple statement by using the compound statement or braces. If this thing is true, this part is executed. If this thing is false, this part is executed. That's the general flow of if statement. If it is true, this part is executed. If this is false, this part is executed. That's all.
Sir, can we use more than one expression inside the parenthesis?
If we use combine with and, we can, but if you want to evaluate, like if a number is more than 20, I will do one thing. If it is more than 30, I will do another thing. If it is more than 40, then there's something called cascaded if statement, which the most common form looks like this. But like don't get confused, it's basically this if, and then this if nested inside this else, and this if nested inside another else. So that's just cascaded if statement. We'll take a look at them in the next class. And finally, we'll try to write a program that will print your like GPA or GP and grade based on the marks that you have got. This is the whole table. We'll try to solve this one in the class. Okay.
Okay.
In next class. Okay. Thank you very much, everyone. I'm well past my time, and I think a lot of you joined today. And okay. So thank you. I will stop the presentation and recording now. Do not leave now. Just let me take a look at whom of you are present, and later on I'll just give your attendance from there.
Sir, I student roll 133. He was joining from the first, but now his electricity has gone.
What's his name?
Tamim Shorkar.
Tamim Shorkar was here. I have seen him. Okay.
Yes.
Don't worry. So in between class, I actually noticed who are here and who are not, and so yeah, I'm trying to like memorize the names or at least voices of all of you. So I'll try as much as I can. I know Tamim was here, and also he is the seer.
Yes, sir. He called time before I go to let me know you.
Yes, it's fine. I think except some of you, all of you are present now. I'd like to just ask one thing. Jannatu Samaruk, you are the seer, right? You're also another seer.
Yes, sir.
Okay. You people can, Jannatul, you stay, and rest of you can leave the class. If you want to.
Should I stay too?
Oh, Tamim, you're back.
Yes, sir. Yes, my electricity was gone.
Just stay for like a couple of minutes, okay?
Okay, sir. Okay, sir.
Assalamu alaikum, sir.
Wa alaikum assalam. Okay, so like Muhammad Arafat Hussain, you people are section 1, yes. Muhammad Arafat Hussain Anjar, this person, and Sabir Alam Saad. Anjar's roll is 04, and Saad's roll is 52. So what's up with these two people? Do they not want to continue anymore in IIT? In that case, if they can let me know, I will just simply strap off their name from the attendance sheet. Because sometimes not attending a semester is better than not doing class. Because you know that the rule of IIT, if you do not attend up to a certain percentage, you will not be allowed to sit in the exam.
Yes, sir.
Okay, so do you happen to know anything about those two people?
No, sir. We couldn't contact them. I also they don't join other classes too. So I tried to contact them, but I didn't get any response from them. I emailed them from getting the email from the Google Classroom, but they didn't respond.
They joined the classroom, right?
Yes, sir.
Yes, sir. One of them joined the classroom. I think it's 04.
Okay, yes, I also think I have seen his name in the classroom. Like about Sabir Alam Saad, I couldn't find him anywhere.
No, sir, I couldn't find him too, but I found Anzar and I also emailed him, but no response.
Okay, got it. Okay, anyways, so you people tried, so then it's fine. It's my duty to give the warning. Since you people already tried and couldn't give the warning, then it is fine, okay? So that's it for today's class. Thank you, everyone.
Okay, sir. Shall we leave?
Yes, you can leave. All of you can leave. Have a good day.
Thank you. Sorry.
Okay, sir. Assalamu alaikum, sir.
Okay, sir. Assalamu alaikum. Have a good day.
Wa alaikum assalam.